Welcome back to episode 18. We are diving into the fascinating world of personality psychology to explore the work of Hans Jürgen Eysenck, one of the most influential figures in understanding human temperament. Eysenck proposed that our personalities aren't random but are deeply rooted in biological factors like extraversion, neuroticism, and psychoticism, helped shape how psychologists study and measure temperament today. So let's take a closer look at how Eysenck transformed our understanding of what makes us who we are. Hans Jürgen Eysenck was a British psychologist and one of the most influential figures in 20th century personality research. He was born in Germany and lived between 1916 to 1997. He moved to England during World War II and became known for applying scientific and statistical methods to the method of human personality. Eysenck's work helped establish personality psychology as an empirical science, using experiments and measurements rather than philosophical theories. He developed a biological model of personality, proposing that our temperaments are influenced by inherited brain and nervous system characteristics. He believed that personality could be understood through measurable dimensions rather than separate categories. His early work focused on two major dimensions. The first one is extraversion, introversion, that is, how socially outgoing or reserved a person is. The second is neuroticism, stability, that is, how emotionally reactive or calm a person tends to be. He later added a third dimension, which is psychotism, and is linked to creativity, nonconformity, and sometimes aggression. Eysenck's model explained that extroverts have lower baseline brain arousal, so they seek excitement and social interaction to feel stimulated. For introverts, he said that they have higher baseline arousal, so they prefer calm, quiet environment to avoid overstimulation. High neuroticism means being more emotionally sensitive, anxious, or reactive. Low neuroticism means being emotionally stable and calm under pressure. So, by combining these traits, Eysenck's system aligns closely with ancient four temperaments: the extrovert as the sanguine and the choleric, while the introvert as the phlegmatic and the melancholic. Eysenck's theory became one of the most influential frameworks in modern personality psychology. He created tools like Eysenck's personality questionnaire (EPQ), which scientifically measure temperament traits. His biological explanations inspired further research into the neuropsychological and genetic basis of personality, influencing later models such as Big Five, that is the ocean, and neurological theories of emotional regulation. While Eysenck's work was groundbreaking, some critics argued that his focus on biology overlooked environmental, social, and cultural influences on personality. Others found that the psychotism dimension was too broad and not clearly defined. Over time, researchers refined his ideas into multidimensional trait theories, particularly the five-factor model, which expanded his two main traits into five broader categories. Eysenck's model remains the foundation of modern personality science. Today's popular psychological tests, including those used in career, counseling, clinical practice, and personal development, owe much to his approach. His alignment of ancient temperament theory with modern biological psychology makes him a key bridge between historical temperament thinkers and contemporary neuroscience. In essence, Eysenck gave scientific depth and measurement to what began as philosophical idea over 2000 years ago. And that wraps up our look at Hans Eysenck's contribution. His work laid the foundation for modern personality research and continues to influence psychology, neuroscience, and even everyday personality testing. Whether you see yourself as an introvert, an extrovert, or somewhere in between, Eysenck's theories remind us that personality is both measurable and meaningful. Don't forget to like, subscribe, and share. Thanks for watching. I'll see you in the next episode. Bye.